Good morning. I hope everyone's excited and strapped in. I have the great pleasure of inviting everyone in for science-related projects, experiments that will be hosted by our corporate partners, which include DuPont, Boeing, FMC, ILC Dover, and Elite Universal Network.
Hi, I'm Maggie Eicks, and I am here to talk to you about STEM and how to solve complex problems. But before we get started, I would like to show you a STEM motivational video and how STEM is used in our everyday life. Is that a cool video or what? I am super excited to get started, but before we get started, I would like to talk to you a little bit about myself. So I was born in College Station, Texas, born and raised in Texas, and I currently live in Philadelphia. I have one older sister. She lives in Austin, Texas. I currently have my Bachelor's of Science degree in Industrial Engineering, and I am currently getting my Master's in Systems Engineering. For interest, I like to run, bike, swim, travel to different places. One of the places that I just went to with my girlfriends was Yellowstone National Park. We got to see bison and bald eagles and drive around in snowmobiles. It was really fun. Outside of doing fun activities, I used to work at Schneider Electric before Boeing as a manufacturing engineer. And with Boeing, I've had a couple of different positions ranging from Boeing Research and Technology, Industrial Engineering, Production Engineer, and Operations Manager. So at Boeing, we build all sorts of stuff. We build commercial aircraft, we build space aircraft, shuttles, satellites. We build defense aircraft, so the jets that go really, really fast. So we build all sorts of stuff. Those are just to name a few. So how do we get the aircraft to fly? So there's 4 main forces to help the aircraft make flight. Those 4 are lift, So how do we get the aircraft to go up? We have thrust, that is to get it to go forward. The drag, to go slow, and most importantly, to help with direction. Either going left or right, that's mostly for drag. And then we have weight. So the weight is how much can we lift up. For example, the Chinook on the defense side, that is huge with weight. It helps carry cargo from one point to another. So those are the main forces to make the aircraft fly. So how do we do that? How do we make that happen? We have engineers and scientists at Boeing to help make that happen. The types of engineers at Boeing, for example, are aerospace, chemical, civil, computer, industrial, like me. And then we have scientists like physics and chemists and material scientists. All of these engineers and scientists really help drive to solve complex problems. From my own experience, the best thing I've done is I built and designed an assembly line. That really helped open up my eyes and give me insight that I was really interested in technology. So with that understanding, I was able to combine my interest in technology and my industrial engineering background to look at cycle time studies, lean manufacturing. How do we implement robotics and automation, and really look at the process to help drive process improvements? For example, how to make a peanut butter jelly sandwich faster. How do we get the jelly on faster? How do we get the peanut butter on faster so that we can eat the peanut butter jelly sandwich quicker? Those are typically things that I do every day, is just really look at the process to see how to make the process faster, either through technology, through robotics, through a tool, all sorts of stuff to make the process faster. So what was I like in high school? I was not interested in technology. It was very opposite. I was fully interested in athletics. But with athletics, I was able to build team skills, team collaboration, working together as a team, learning how to communicate as a team, and really help drive and share the same goal as a team. I use those skills every day, those team collaboration, team-oriented skills, to be able to help solve complex problems in my day to day. So what kind of skills are those? We have problem-solving skills. We have conceptual understanding of science and engineering. That one's a pretty big one. For example, we know that 1 + 1 = 2. We're able to use that base understanding to help solve even more complex problems and to really expand our understanding of the base conceptual understanding to help drive process improvements and to solve complex problems. So really understanding the basis is a big part of success. So what skills do we use? Curiosity, creativity, and persistence. Persistence is a key item. Don't ever give up. Rarely do I ever get it right the first time. It's that persistence in trying again, over and over again, until you achieve what you set out to achieve. And that continuous drive will help make you become successful and help solve that complex problems. So persistence is a huge part of it. So how do they help us grow? It creates unique solutions, innovation, and encourage to redesign. So how do we get that part smaller? How do we get that part stronger? How do we get the part shaped differently? It's that encouragement to redesign to really help drive innovation and a new creation. For example, the 787. Before the 787, it was all aircraft were metal. That one's fully composite. Is that will help us drive innovation. So how do we get there? These are a couple of steps that engineers, scientists use to help solve complex problems. Drive inspiration. So you could drive inspiration through outside, through talking to someone, through art, through daydreaming. Inspiration is drive through all sorts of things. So after you have that inspiration, then you want to create a plan of, okay, what is our steps to achieve our goal, to achieve whatever we set out to accomplish? What materials do we need? What kind of tools do we need? So that plan gives you a really good base understanding of what direction you want to go into. So now it's time to build. So let's build and test it out and see what we learn. See what works, see what doesn't work, see what we want to change. So with that knowledge, we're then able to redesign. And then let's build again. Test, redesign, build, test, until we achieve what we want to and we're happy with it. Once we're good with it, then we want to reflect. We want to say, okay, what did we learn? What went right? What went wrong? What do we want to change? And how do we want to continue to move forward? It's with these steps that will help us get to where we want to design, and also to help solve complex problems. So who goes through these engineering design processes? Everyone does. Not just scientists, not just engineers. Everyone can go through the process to help solve complex problems. All right, now it's time for us to start designing and building. Our challenge today is design and build an airplane that can fly at least 10 feet forward while carrying a paperclip. So I'm going to stop sharing and I'm going to go over here where my materials are, and we'll go ahead and get. All right, so you can see that I have my prototype. So this is our main goal. How do we get an aircraft to hold a paper clip? All right, I'm going to set that aside. So I got my sheet of paper. I got my different size paper clips. All right, so I'm going to first fold over this. And I'm thinking this might be a little too big. All right, I'm going to fold this over one more time. All right. Oh, let's redesign. I wanted to get that flat. All right. Perfect. So now we got our body. Now it's time to make our wings and our nose so that we could thrust forward, and also we can get that lift that we want to be able to fly 10 feet. All right, I'm going to do that to the other side. All right, perfect. Now let's build our wings. I think I'm going to go like this. Perfect. I'm going to do the same thing to the other side. All right. I think I got my base of my airplane. Now it's time to add the paper clip. I'm going to try this one. See if this works. I don't know. I think it might be too small. So I'm going to redesign, and I'm going to get a different paper clip. I'm going to go with this paper clip. See how it goes, how it does. All right, perfect. Well, I'm excited because I think it's time for me to test it out. So this is my aircraft. I'm going to go outside and I'm going to test it out and see what happens and learn and redesign for it to be able to fly 10 feet while holding a paper clip. So I want to say good luck to everyone, and always remember, never give up.